this video we'll be covering notes on the quadratic formula. Now, in the last lesson we talked about solving quadratics by factoring, but actually sometimes you cannot solve quadratics by factoring. So that is when we get something that looks like it's prime, there actually still might be an answer. However, we can't solve it by factoring. So we have a formula that allows us to solve a quadratic if we cannot solve by factoring. And you may have seen this before, but we're actually going to learn how to use it. So first of all, if you'll write this down, if you have ax squared plus bx plus c equals 0, so remember that's the standard form of a quadratic formula, a trinomial, and a does not equal 0, so that is, it has to be an x squared. Then we have the quadratic formula, and this is actually something you need to memorize. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so this is something that I would write down nice and big in your notebook, and then I would also just very make it highlighted, just make it really stand out in your notebook. Okay, so that is something that you will need to memorize. Okay, and some of you may have actually heard this before, but there's a little song that goes with the quadratic formula. It goes to the tune of Pop Goes the Weasel, and instead of singing it myself, I found a video on it, so I'm going to let you hear this video, and hopefully you can hear it.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, so I hope you enjoyed that. So now we're going to actually see how this works. And we're going to start off with an easy one. So to write this example down, solve 2x squared plus 3x minus 5 equals 0. Now remember, in order to solve, we have to have an equation, and our equation for a quadratic has to equal 0 in order to solve. So this one you could actually solve by factoring, but I'm going to start off with an easy one so we can get easy numbers at the end, and then we'll move on to see why we actually need to use the quadratic formula. Okay, so first of all, we want to have ax squared plus bx plus c, so a equals 2, and then b equals 3, and c equals negative 5 for this problem. So as we just follow this formula, so remember when we're solving for a quadratic formula, we want to solve for x. So the beginning of the quadratic formula says x equals negative b. So that would be negative, b is 3, so negative 3 plus or minus the square root of b squared. Now make sure I would put this in parentheses because sometimes b will be negative itself, so you want to make sure and square that. Minus 4 times a, and I like to put the a and the c also in parentheses because look at that, c is negative 5, and so you would want to make sure you're multiplying by negative 5. So that's negative b plus or minus the square root of all that, all over 2 times a. And so 2 times a would be 2 times 2. Now you're simply just going to simplify all of that. So negative 3 plus or minus the square root of 9. And now if I have negative 4 times 2 times negative 5, that would actually be a positive because of the negative times the negative. 4 times 2 is 8, and 8 times 5 is 40. So that would actually become positive 49, all divided by 2 times 2 is 4. Keep going, and now you can see that inside our square root we have 49. And the square root of 49 is 7. So we have negative 3 plus or minus 7 all over 4. Now this plus or minus means typically when we are factoring, remember we have 2 answers most of the time. So that's where you get the 2 answers. So from here you would take this and say I would have one answer that would be negative 3 plus 7 over 4. And I would have another answer that would be negative 3 minus 7 over 4. So in the top, negative 3 plus 7 is 4 over 4, so you get an answer of 1. And in the bottom, you have negative 3 minus 7, which is negative 10 over 4, which when you reduce that is negative 5 halves. Okay, so then my final answer is going to be, again, you want to write your final answer, down at the bottom, and so that would be negative 5/2, comma 1, and that is my answer. Now again, you could have done this by factoring and gotten the same answers, but I just want to show you how to do factoring so that when you cannot factor, you know how to do it. Okay, so let's look at an example that actually does not factor. So you would know that it does not factor. So what I would typically do if I told you to solve something, and I didn't tell you necessarily use quadratic formula or to factor, I would always try factoring first because it's a little less work. So if I were to try factoring this one, you would get a times c is negative 12, and then you would try to find factors that add to get 2. So you have 1 and 12, 2 and 6, 3 and 4. And if you look at each of those factors, and again I'm subtracting to get negative 12, so in order to subtract to get 2, there really is no pair that can do that. So what we would have done in the past is say this is prime. However, what this means is you could still probably get an answer for x. It just means x is going to not be like a whole number or a rational number. It's probably going to be some kind of decimal. And so sometimes that happens and we can still get an answer for x. So let me show you how that works. So since this does not factor, then we're going to use the quadratic formula, which again is negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, that's something that you would need to memorize. Okay, so if we did this, a is 3, b is 2, c is negative 4. So our x value that we want to find is negative b, so negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a times c, all over 2a, which would be 2 times 3. Okay, continue on, and we have negative 2 plus or minus the square root of 4, and then we have negative 4 times 3 times negative 4. Again, we have a negative times a negative, so that's going to be a plus. 4 times 3 is 12, 12 times 4 is 48, all divided by 6. So then this becomes negative 2 plus or minus the square root of 52 all over 6. Now, in example 1, we had that our square root was 49, which we knew that square root. That's a perfect square, so you would get 7. But however, in this one, we have 52, which is not a perfect square. So if you get not a perfect square, that's why your original answer was not, you could not factor it because you get not a perfect square. So if you do get a perfect square, when you're solving a quadratic like that, like the first one, then that means it was factorable in the beginning. But when you cannot factor, you're going to get an answer that is not a perfect square. So then what you can do for this one is sometimes they want you to leave your answer like this. But sometimes you can actually get a decimal answer, but you're going to have to put that into the calculator. So again, if you were to put this in the calculator, I would put negative 2 plus the square root of 52 divided by 6. So that would be one answer. And then the other answer would be negative 2 minus the square root of 52 divided by 6. Okay, so I took my calculator and I found my two answers. My decimal answers would be these two answers. Okay, so like I said, sometimes in math we will want to leave it in this format here, and then sometimes you would want to get decimal answers, which you would have to use your calculator there. So notice that I still got an answer, but I have such nasty, ugly looking answers because I could not factor at the beginning. So this problem actually was not prime in the sense that it didn't have any values of x that could solve for it. It just wasn't factorable into perfect numbers. Okay, we're just going to solve a couple more examples just to see some other cases what happens when you do the quadratic formula. So this one is x squared minus 6x plus 9. I made a typo there. So it's plus 9 equals 0. We want to solve this by using the quadratic formula. Okay, so again, we have a is 1, b is negative 6, and c is 9. So let's see if we can remember the quadratic formula. So negative b would be a negative of negative 6. Now, if you saw that ahead of time and saw negative of negative 6 would be positive 6, it's okay if you just wrote 6 there. Then plus or minus the square root of b squared. Here's where you need to make sure your b is in parentheses, because negative 6 in parentheses squared will actually end up being positive 36. So that's why parentheses are very important. Minus 4 times a times c, all divided by 2a. Okay, when we simplify this down a little bit, we have a positive 6 plus or minus the square root of 36 minus 4 times 1 times 9 is also 36 over 2. And so now you can see what's happening there is we have 36 minus 36, which is just 0. And the square root of 0 is just 0. All right, and so if you have 6 plus or minus 0, whether you add 0 or subtract 0, that really doesn't matter. Okay, so here, the plus or minus really doesn't come into play because I'm adding or subtracting 0. So for this example, you actually are only going to get one answer. So sometimes when you solve quadratics, you will only get one answer. And sometimes, a lot of times you get 2, but sometimes you will get 1, and that's okay. Okay, for our final example, again, this is going to look even different. So if we have a equals 1, b equals negative 6, and c equals 11. Solving by quadratic formula, we have x equals negative b, so we have negative of negative 6, which is just going to be a positive 6. So again, if you can think of that, then that's okay. You can just go ahead and write positive 6. Plus or minus the square root of b squared minus 4 times a times c, all over 2a. So simplify that, you get 6 plus or minus the square root of negative 6 squared is positive 36, then minus 4 times 11 is 44, divided by 2. And then we have 6 plus or minus. Now 36 minus 44 would actually give you a negative 8, and then divide by 2. So the square root of negative 8, that actually, you cannot do anything with that. So remember that when we took square roots, that what's underneath the square root has to be positive. So if you get a negative under a square root, then this is not possible. Okay, so sometimes a quadratic formula, you actually don't have an answer. And so the quadratic formula will show you that, in that if you get a negative under a square root, you can't find something times another number to get a negative, because a positive times a positive is a positive, then a negative times a negative is a positive. So you cannot take the square root of a negative number. So the answer here would actually be no solution. Okay, so if you have a negative under the square root, then the solution to that quadratic would be no solution. Okay, so you have 3 different types of solutions when you do the quadratic formula. You could have no solution if you have a negative under the square root. In example 3, we had a 0 under the square root, so we only had one solution. And then we also had where we had a positive under the square root, which gave us 2 solutions. Okay, so that's the quadratic formula. So make sure you're working on memorizing this formula, because that's very, very, very important.